Hey guys, welcome to this video on implicit differentiation. So far, you've probably been able to find derivatives of functions like in the case of each of these functions, y, or also r, is equal to some function of x, and if we know x, we can then solve for y directly. When this is the case, we call this an explicit function. Now, an implicit function, on the other hand, is when you have a function of y and x that is equal to something else, like in these functions, for example. Well, these are simple enough. If you wanted to take the derivative, you could just solve for y and then take the derivative with respect to x. And for these functions, it's true. You can just simply solve for y and then take the derivative with respect to x. The problem, however, is that this can't be done with every function. So then, in order to take the derivative, we will need to leave it as it is and take the derivative that way. This is what we call implicit differentiation. And implicit differentiation is just an application of the chain rule. So as you try and navigate through thinking what on earth is implicit differentiation, just think chain rule. Let's take a look at an example, and I'll show you what I mean. We've already found the derivative of x squared plus y squared is equal to 16, but let's find the derivative using implicit differentiation. What's happening with our d over dx times y squared here is what's intriguing, because y is a function of x, and we're taking the derivative of y squared with respect to x, which means we must apply the chain rule. So here's what it would look like to then apply the chain rule. So when we apply this to this right here, here's what we get. Now, we have the derivative of y with respect to x in our equation. So then all we would do at this point is subtract our 2x over to this side and then divide by 2y. So that would give us . Now, this is different than what you're probably used to seeing when you have y explicitly defined as a function of x. But now what we have is our derivative in terms of x and y instead of just x, like in our explicitly defined function. All right, let's take a look at another problem using implicit differentiation. So to start, we need to take the derivative with respect to x of both sides. Now, our left side here is pretty simple, but to make this side a little simpler, I'm going to rewrite the square root part. Now we just take the derivative. To the right of our equal sign, we can take the derivative of our 7 and our x squared plus y squared all to 1/2 separately because it's addition. But with our x squared plus y squared to the 1/2, we'll have to use the chain rule. Then technically use the chain rule again as we take the derivative with our y squared with respect to x. So at this point, we've taken the derivative, and now we just need to do some algebra to get our dy over dx by itself. I'm going to go ahead and rewrite this by placing our x squared plus y squared all to the negative 1/2 in the denominator, and then factoring out a 2x from our 2x plus 2y here. So at this point, our 1/2 and our 2 will cancel out once they multiply together. And then we'll go ahead and multiply both sides by the square root of x squared plus y squared so that we can start to get dy over dx by itself. Now we just need to subtract our x here So now the last thing that we need to do to get dy over dx by itself is divide this whole side by y. And there's our answer. I hope that this video has better helped you to understand implicit differentiation. For further help, be sure to check out more of our videos by subscribing to our channel below. See you next time.